Good morning, students. Today we will continue with our chapter number 9, Carbon and its allotropes. Today we will study about another crystalline form of carbon, that is graphite. Graphite is a grayish black colored substance. As you can see in the figure, it is smooth and slippery to touch. Graphite occurs naturally in Sri Lanka, Mexico, Austria, North Korea, China and India. In India, it is found in Bihar, Odisha, Tamil Nadu, Rajasthan, Andhra Pradesh and Jammu and Kashmir. In graphite, each carbon atom is bonded to 3 carbon atoms. As you can see in the figure, this one carbon atom is bonded to 3 carbon atoms. These form hexagonal planar rings. The shape you can see, it is hexagonal. These hexagonal planes are arranged one above the other, giving rise to a hexagonal layered structure. You can see different layers are formed in graphite. The carbon atoms within a layer are bonded by strong forces of attraction. However, the carbon atoms of one layer are bonded to carbon atoms of another layer by weak forces of attraction, and hence each layer can easily slip over another layer. This makes graphite soft and slippery, hence it is a good lubricating agent. Preparation of graphite. Graphite can be prepared artificially by heating the powdered coke with little sand and ferric oxide in an electric furnace to a temperature of about 3000 degrees Celsius. So it forms carbon monoxide and silicon carbide. Silicon carbide, in the presence of ferric oxide, breaks into silicon and graphite. Properties of graphite. Graphite is a natural grayish black colored, opaque and crystalline substance. It is soft and slippery to touch and possesses a metallic luster. It is the most stable allotropic form of carbon. It is a good conductor of heat and electricity, since each of its carbon atoms has one free valence electron. Its density is 2.3 gram per centimeter cube. It has a high melting point and boiling point. It burns in air at 700 degrees Celsius to form carbon dioxide. At high temperature and pressure, and in the presence of some catalyst, graphite changes into diamond. It is insoluble in any solvent. It remains unaffected by acids and alkalis. Uses of graphite. Graphite is used in making the core of lead pencils. It is used as a lubricant in fast moving parts of machinery. It is used as a moderator in nuclear reactors to slow down the speed of the neutrons. It is also used to make the crucibles, the melting pot for melting metals. It is used as electrodes in batteries and electric furnaces. Carbon brushes of electric motors are made of graphite. We will do an activity to demonstrate that graphite is a good conductor of electricity. For this, the materials required are a graphite rod, a battery, switch, bulb, and insulated copper wire. We take a graphite rod and connect it to a battery, switch, and bulb using an insulated copper wire to form a complete circuit. Now we turn on the switch. We will observe that the bulb starts glowing. The bulb glows because of the conduction of electric current through graphite, proving that graphite is a good conductor of electricity. Differences between diamond and graphite. Diamond is colorless and transparent in pure form. Graphite is grayish black and opaque in pure form. Diamond has an octahedral structure. Graphite has a hexagonal structure. Diamond is the hardest occurring substance in nature. Graphite is soft and slippery to touch. Diamond is a bad conductor of heat electricity. Graphite is a good conductor of heat and electricity. Diamond burns in air at about 900 degrees Celsius to form carbon dioxide. Graphite burns in air at about 700 degrees Celsius to form carbon dioxide. Density of diamond is 3.5 gram per centimeter cube and density of graphite is 2.3 gram per centimeter cube. The next crystalline form of carbon is Fuellerine. The number of carbon atoms in its molecules can vary from 20 to 900. One of the most common Fuellerine contains 60 atoms of carbon and is denoted by C60. It has a molecular structure that looks like a football or a dome. It is known as Buckminster Fullerene after the name of the American architect Richard Buckminster Fuller. It is also known as buckyball because of its spherical structure. It is a hollow spherical structure in which 60 carbon atoms combine. It looks like a tiny saucer ball with an atom of carbon at each point where the lines on a saucer ball would normally meet. The carbon atoms are arranged forming pentagonal and hexagonal rings. C60 can be prepared artificially by condensing the vaporized graphite in the presence of helium. Properties of Fuellerine. The color of Fuellerine varies according to the number of carbon atoms present in its molecule. It occurs in nature in small quantities. It exists in interstellar dust, particles of matter found in space between stars and the geological formations of the earth. It is soluble in many solvents. It is stable but not totally unreactive. Density of Fuellerine varies from 1.8 to 2.1 gram per centimeter cube. It is more active than diamond and graphite. It breaks when heated to plus or minus 1000 degrees Celsius. It is a bad conductor of electricity, but some compounds of Fuellerines, when mixed with alkali metals at high temperature, they may become the superconductors. The uses of Fuellerine. It is used as an insulator because it is a non-conducting in nature. Some compounds of Fuellerine are used as superconductors. It is used as a catalyst.